Hello, Lovelace. Welcome to today's science lesson. I hope you are all keeping safe and well. As you can see, we're carrying on with our work with materials and their properties, and the focus is the same as our last lesson, in that we're looking at thermal insulators. So do I understand what a thermal insulator is for? Remember, thermal is all to do with heat. An insulator is keeping that heat inside. So just like last lesson, we need to be able to know what conduct and insulate mean. We need to make predictions using our existing knowledge. And we need to investigate which materials are efficient thermal insulators. Okay. So last time, your task was to test the insulation properties of different containers. Hopefully you've completed that now that you're looking at this video. I asked you to collect a selection of material containers from your kitchen. So here's the four I got, the four samples I used for this experiment. It's entirely up to you what you've got available. All I asked was that there were different materials. So in this case, I had a clay mug, a glass, a metal pan, and a plastic Tupperware tub. Okay. Hopefully, when you were using the hot water, you were very, very careful and had adult support. And that is going to be the same again today. Okay. Once you'd put your hot water in, I asked you to wait for 10 minutes to see which container had kept the water the hottest. So by now, if you're watching this video, hopefully you've already done that experiment and you know which of your containers, which material was the best at keeping the heat in, which was the best thermal insulator. Now, I did comment at the time that this wasn't a totally fair test. And the reason for that is that the containers were different sizes. And by being different sizes, then it would allow a slightly different rate of cooling. So I fully understand that this was not a totally fair test, but it gave us an idea as to which of these materials were the best insulator. Okay. So hopefully by now, you know which of your containers and therefore which material was the best insulator. You are great scientists, but we need to move it on a step. So your challenge this time is, can we make them even better? Now, I want to give you a little bit of information, a little bit of thinking time before we get to that particular challenge. Okay, but that is going to be our challenge for today. Can we make these containers better insulators? Now, if you're cold, and at the moment it's pretty cold outside, if you get cold, it basically means that your body's heat is escaping. Okay, it's escaping into the big wide world. So you need to keep that heat in with some sort of insulating material. Okay, now here we have two people dressed for the cold. On the left, these are wearing man-made fibers. Okay, so these are nylons and various other fabrics that are man-made, designed to keep people warm. So these would be very quilted jackets, puffer jackets, designed for cold weather. But on the right, we've got an Inuit here, someone who's lived their entire life in the Arctic Circle, and they have learnt to fashion their clothing from animal skin. So these are natural materials, but doing the same job. Now, something you might have been told by mums and dads is that you're going to stay far warmer if you're wearing lots of thinner layers than one big thick layer. And there's a simple reason for that. There is some science behind that, because lots of thin layers trap air between each layer, and that air will stay warm. Okay? So lots of thinner layers work better than one big layer. And that's because the air that's trapped between the layers is warmed by the body and stays warm until eventually it finally escapes through the materials. Okay, so those layers of air do just as good a job keeping you warm as the layers of material. And if you imagine with one big thick layer, there's not going to be as much air trapped. So we use this idea in lots of ways around the house. If you've got a hot water tank in your house somewhere, it will be insulated, it will be wrapped in some way. So we wrap hot water tanks, so once the water has been heated, it stays warm for longer. This saves energy and saves money. Windows are double glazed. This means more heat stays inside the house, and this saves energy and money. So there is a layer of air trapped in between the two glass panes, and that layer of air acts as an insulator. Okay, we've got three things going on here. Very, very simple things. Simple things like draft excluders or just closing the door stops heat from escaping. And all these things save energy and save money. This is a proper draft excluder. So it's fitted to the bottom of the door, and you can see it blocks any cold air from getting underneath. This is a draft excluder that you just throw against the door, so it doesn't fit perfectly. You can see there's gaps either end, but it does a pretty good job. And then just simply closing the door will keep most of the air, the hot air, trapped inside. Okay. So, can we make our containers better thermal insulators? That's the question for today. That's your challenge. Once again, and I cannot say this often enough, this is a heat experiment. We are going to be using hot water again, and it is really, really important that you have an adult helping you when you're setting up this piece of work. Okay? I don't want any messages coming into school that someone's been injured by playing with hot water. So please, guys, make sure you're getting adult support when you're setting up your experiment. You can do big parts of this by yourself, but when it comes to the hot water, please ask for help. So your task, choose one of your containers that you've got a few of. 4 would be ideal. You might not have 4, but say whatever. So those are the 4 I used in my experiment. I had clay mug, glass, a metal pan, and a plastic Tupperware. Now, when I went through my cupboards, I realized all my pans were different sizes. I didn't have any pans the same size. It was the same with the Tupperware. I had a few bits of Tupperware lying around, but they were all completely different sizes. Glasses. Yeah, I could have used glasses, but I thought, actually, when I went through my cupboards, I had 4 mugs exactly the same. So that's what I decided to do. I got 4 mugs. So I've got 4 containers of the same material. Okay. And what I need to do now is to use different soft materials to wrap each of those containers. Okay, so you're creating a jacket, an extra layer to hopefully keep your water warmer for longer. So a couple of examples there. Maybe get a woolly sock and wrap it around your mug. Okay. That could be one example. Another example, maybe tin foil and wrap that around the mug. Now, once again, this isn't a perfectly fair test because depending on the materials you're using, they're probably going to be different thicknesses. Now, if this was a totally fair piece of science, we would make sure that our jackets were the same size, the same thickness. So the only thing being tested was the material they're made of. Now, I think as we're collecting things from around the house, that's going to be pretty difficult. So we need to accept that this isn't a perfectly fair experiment, but again, it will give us an idea. It will give us a sense of which of these materials make the best thermal insulators. So hands up, I accept this is not totally fair, but we can still go ahead and do our very, very best to complete the science as fairly as possible. So there's your task. to wrap each of your containers with your choice of soft material. My first couple of examples would be wool, and the easiest way would be just to wrap a woolly sock around it, maybe some tin foil, and think about other materials, other soft materials that you could use to wrap around your containers. Very, very carefully pour hot water into each container. Once again, about half full. There's no need to come up to the top of the container. I don't want any dangers of spills, so half full is absolutely fine. And have a think to yourself, predict, which jacket do you think will be the best thermal insulator? Which jacket do you think will keep the water warmest for the longest? And then just like last time, wait. Okay, this would be a perfect opportunity to take a photograph of your containers in their smart little jackets. And because as well as your results, it would be great to see a photograph on Tapestry of your mugs, glasses, pans, whatever your containers are, wrapped up in their beautiful little jackets. So whilst you're waiting, take a photo. After about 10 minutes, go back and carefully remove the wrappings. I don't want any water being spilt. It's still going to be quite hot. So carefully remove the wrapping. And then just like last time, I want you to gently feel the outside of the containers. Okay. Which one do you feel has kept the water the hottest? Which one next? Which one next? Which one next? Okay, so you're going to rank them. If you've got a thermometer available, then you can certainly use that to give you even more precise measurements. But don't worry if you've not. Just touching the container carefully with your hand will give you an idea as to which one's the best and which one's the worst. Once you've done that, as I say, rank them from the best insulator. So the best one, number one, is the one that stayed the hottest. Number two is next, 3, 4, and so on, down to the worst. So this is the one where the water has cooled the most. And finally, I want you to create a table of results. So just like last time, listing the materials, but this time the materials of the jacket, and then ranking them from first to last. Okay, hopefully that's all clear. Please, guys, be safe. Be safe using the hot water, and obviously be safe around COVID and everything else that's going on at the moment. I am looking forward to seeing a photograph together with your table of results on Tapestry. But that's the end of today's session. Take care of yourself and take care of those around you. See you all soon.